एवरीवन, वेलकम टू यूनिवर्सिटी एकेडमी यूट्यूब चैनल। आज के लेक्चर में हम लोग देखेंगे इनवर्स लैपलेस ट्रांसफॉर्म एंड रिप्रेजेंटेशन ऑफ सर्किट एलिमेंट्स इन एस डोमेन। सो लेट अस स्टार्ट विद द इनवर्स लैपलेस ट्रांसफॉर्म। So suppose we are having a signal in the time domain, suppose it is represented by x of t. So अगर उसके ऊपर हम Laplace transform अप्लाई करते हैं then we will be getting the expression in the s domain which is represented by x of s. It means x of t का जो Laplace transform है is x of s. Now we have the equation in s domain and we want to go back into the time domain. So for that now we are having x of s, that is equation in s domain, and we want to go back into the time domain. So for that we have to use inverse Laplace transform. Okay, so it means x of t को हम x of s में convert कर सकते हैं and x of s can again be converted into x of t. So it is bi-directional process. Okay, in the previous lecture we have seen the Laplace transform formula which is given by x of s, it is equal to integration from minus infinity to plus infinity x of t e to the power minus st into dt, where s is a complex variable given by sigma plus j omega. Now the inverse Laplace transform formula is given by, so inverse Laplace transform formula is given by, so now we have to find out x of t, then it is given by 1 by 2 pi j integration from sigma minus j infinity to sigma plus j infinity. So now it will be x of s into e to the power s into t. So this will go on the left hand side, so it will become e to the power s into t into d of s. Okay, so this is the formula to find out the inverse Laplace transform of any signal. Now let us see a question. Find the inverse Laplace transform for the x of s, it is equal to s plus 3 by s plus 1 into s plus 2 whole square. So now यहाँ पे हमें x of s given है, we have to find out inverse Laplace transform. It means we have to find out the signal in the time domain, that is x of t. Okay, so x of s given is s plus 3 divided by s plus 1 whole divided by s plus 2 whole square. Okay, so now we will solve using the partial fraction. So सबसे पहले इसके fractions बना लेते हैं, that is a by s plus 1, and because it is s plus 1 is a linear function, then b divided by s plus 2. So here s plus 2 is a repetitive pole. Okay, so b by s plus 2, then c divided by s plus 2 whole square. So now we have to find out the value of a, b and c. So in order to find out the value of a, so in the a denominator it is s plus 1. So if we substitute s plus 1 is equal to 0, we are getting s is equal to minus 1. Okay, so यहाँ पे हमें क्या है, s को minus 1 सब्सटीट्यूट करना है इन द लेफ्ट हैंड साइड एक्सप्रेशन, बट आपको s plus 1 यहाँ पे सब्सटीट्यूट नहीं करना, बिकॉज अगर यहाँ पे s को minus 1 पुट करेंगे देन इट विल बिकम minus 1 plus 1, that is 0, and in the numerator it will be minus 1 plus 3, that is 2 by 0. So overall it will become infinite. Okay, so आपको s is equal to minus 1 पुट करना है except this term, means इसको छोड़ के बाकी जो terms बच गई उसमें आपको पुट करना है. So let us substitute. So minus 1 plus 3 divided by minus 1 plus 2 whole square. Okay, so this is 2 by 1 whole square. Okay, that is 1 square, so we are getting 2. So it means a की वैल्यू हमें मिल गई, that is 2. Similarly c is divided by s plus 2 whole square. So if we substitute denominator as 0, so we are getting s is equal to minus 2. Okay, now you have to substitute s is equal to minus 2 in this expression except this term. Okay, because अगर आप यहाँ पे minus 2 put कर देंगे then it will become infinity. So let us substitute minus 2 plus 3 whole divided by, so it will become minus 2 plus 1, so that is 1 by, it will be minus 1, so we are getting minus 1. So it means C value we are getting, so C value we are getting -1. Now we have to find out the value of B. So we have substituted -1, -2. You can choose any value. Suppose I am putting S is equal to 0 in the left hand side expression. Okay, so if we substitute S is equal to 0, it will become 3 by 0 plus 1, this is 1, into 0 plus 2 whole square, so that is 4. Okay, now also you have to substitute on the right hand side because we have to find out the value of B. So A value, so let me write first A, and now substitute S is equal to 0, so it will become 1. Then B, if we substitute S 0, it will be equal to B by 2. Then C divided by 0 plus 2 whole square, so this is 4. Okay, so we are getting 3 by 4 is equal to, so if we take the LCM as 4, it will be equal to 4A plus 2B plus C. Okay, so this 4 and 4 will get cancelled out, so 3, it will be equal to 4, and A value we have already calculated, which is 2. Okay, so this is A value and this is C value. So A value is 2, and then plus 2 into B we have to find out, and C value is -1. So this will be equal to 3 is equal to 8 minus 1 plus 2B. So this is 3 is equal to 7 plus 2B. So from here we are getting 2B is equal to -4. It means B we are getting as minus of 2. So B value we are getting -2. So now we have obtained the residues value, that is A B C की value हमें मिल गई. Okay, so B we are getting -2. So suppose this is equation 1. So substitute the value of A, B and C in the equation 1. Then we are getting x of S, it is equal to S plus 3 whole divided by S plus 1 into S plus 2 whole square. Okay, so now A value we have obtained as 2 by S plus 1, so this is equal to 2 by S plus 1. Then B value we have obtained -2, so this is -2 whole divided by, so this is -2 divided by S plus 2, and C value we have obtained -1 whole divided by S plus 2 whole square. Okay, so now we have solved. Now we have to find out x of t expression. So for that we will be using inverse Laplace transform. So after using the inverse Laplace transform, we will obtain the expression for the time domain, that is x of t. Okay, so this is given by 2, and inverse Laplace transform. So we know that in the previous lecture I have told that the Laplace transform of e to the power minus at into u of t, it is given by 1 by s plus a. Okay, so if we apply the inverse Laplace on 1 by s plus a, you will be getting e to the power minus of at into u of t. It means अगर यहाँ पे e की power minus at into ut है, then you will write 1 by s plus a. It means यहाँ पे opposite sign आपका ध्यान रखना है कि अगर यहाँ पे minus a है, then यहाँ पे you have to write plus a. Similarly अगर यहाँ पे 1 by s plus a पे आप inverse Laplace transform apply करते हैं, then you will be getting e to the power minus at into ut, that is opposite sign. Okay, so this is of the form 1 by s plus a, where a value is 1. So you will be getting inverse Laplace transform e to the power, this is e to the power minus, okay, so e to the power a value is 1, so e to the power minus t into u of t. Okay, then it is -2. Again it is form of the form 1 by s plus a, where a value is 2, so you will be getting e to the power minus 2t into u of t. Okay, so you have to write opposite sign. Okay, then lastly we are having 1 by s plus 2 whole square. Okay, so because of 1 by s plus 2, you will write e to the power minus 2t into u of t. Okay, and now it is minus sign, and if it is a square, then t will come. Okay, because the Laplace transform of t into e to the power minus at into u of t, it is given by minus 1 by s plus a whole square. Okay, so I have told you this property. So this is obtained using differentiation in frequency property. Okay, so in the last lecture I have told you this property. So differentiation in frequency property. So this is the answer. Now we have obtained the x of t expression, so we have to find out this. Okay, that is the inverse Laplace transform. So this is answer. Now let us see one more question. Consider the following differential equation of the signal x of t. Okay, so now the differential equation is given, and this is second order differential equation, that is d square x of t by dt square minus 3 into d of xt by dt plus 2 x of t, it is equal to 0, with x of 0 negative is minus 1 and x dash of 0 negative is 0. So these are known as initial conditions. Okay, it means the system is consisting of energy storage element and they are initially charged. Okay, so that is why these are known as initial conditions. Now we have to find out the function x of t. सो अगर हम इस डिफरेंशियल इक्वेशन को टाइम डोमेन में सॉल्व करते हैं देन इट विल बी वेरी डिफिकल्ट बिकॉज दिस इज सेकेंड ऑर्डर डिफरेंशियल इक्वेशन. सो व्हाट वी विल डू इज we will apply the Laplace transform on this differential equation. So when we apply the Laplace transform on the differential equation, it will be automatically converted into a linear equation, and also the initial conditions, they will also taken into the consideration automatically. Okay, so these are few advantages of the Laplace transform I have explained. Okay, so now this differential equation, when we apply the Laplace transform, it will become linear equation. Okay, now after applying the Laplace transform, we will obtain the expression of x of s. Now on this x of s expression, we will apply the inverse Laplace transform to obtain the x of t expression, which we have to find out in this question. Okay, so given differential equation is d square x of t by dt square minus 3 d of xt by dt plus 2 x of t, it is equal to 0. Now let us apply the Laplace transform on the differential equation using property. So using the differentiation in time domain property. Okay, so all these properties I have explained in the previous lecture, so if you haven't watched that lecture, please go and watch it. Okay, so यहाँ पे क्या है कि सेकेंड ऑर्डर डिफरेंशियल इक्वेशन है. सो इसका जो लैप्लेस ट्रांसफॉर्म है, इट विल बी गिवन बाय एस स्क्वायर. ओके, एक्स ऑफ एस, देन एस की पावर क्या है, डिक्रीज होगी, देन इट विल बी s into x of 0 negative, that is initial condition, minus x dash of 0 negative. So this is the differential equation for this term, then it is minus of 3. So what is the differential equation of dx by dt? So यहाँ पे क्या है, फर्स्ट ऑर्डर डेरिवेटिव है, तो s की पावर 1 into x of s minus, then s की पावर will be 0, s power 0 is 1 into x of 0 negative. Okay, then plus 2 into x of s, it is equal to 0. So initial conditions are given, let us substitute the value. So x of 0 negative is minus 1 and x dash of 0 negative is 0. Similarly this is minus 1. Okay, so let us substitute, it will become s square x of s, and minus minus it will be plus s. Okay, this is 0, this is minus 3s x of s, and this is minus, and minus it will become plus 1 into minus 3, it will be equal to minus of 3 plus 2 x of s, it is equal to 0. So now let us take x of s common, we will be getting s square minus 3s plus 2. Okay, so if we take x of s common, we are getting s square minus 3s plus 2. Okay, and the remaining term, that is s minus 3, it will go on the right hand side, that is s minus 3, it will go on the right hand side, it will become minus s plus 3. Okay, so this will be equal to minus s plus 3. So from here we are getting x of s as minus s plus 3 whole divided by s square minus 3s plus 2. Okay, so now here the denominator is s square minus 3s plus 2, so it can be factorized. So we are getting minus s plus 3, that is minus s plus 3. So इसके factors हो जाएंगे, that is s minus 1 and s minus of 2. Okay, so these are the factors of this quadratic equation. Now let us apply the partial fraction. So यहाँ पे क्या है, दो factors हैं, that is a by s minus 1 plus b by s minus 2. Now we have to find out the value of these residues a and b. Okay, सो ए के डिनोमिनेटर में है s माइनस वन, सो सब्सटीट्यूट s माइनस वन इज इक्वल टू जीरो. सो वी आर गेटिंग s इज इक्वल टू वन. सो सब्सटीट्यूट s इज इक्वल टू वन इन दिस लेफ्ट हैंड साइड एक्सेप्ट दिस टर्म, बिकॉज अगर यहाँ पे वन पुट करेंगे इन प्लेस ऑफ s देन इट विल बिकम इन्फिनिटी. ओके, सो दिस विल बिकम माइनस वन प्लस थ्री होल डिवाइडेड बाय this will be 1 minus of 2. So we are getting 2 by this is minus 1. So a value we are getting as minus of 2. Okay, so a value is minus 2. So this is a value. Similarly we will find the value of b. Okay, so in the b denominator it is s minus 2. So substitute s minus 2 is equal to 0. So we are getting s is equal to 2. Okay, so substitute s is equal to 2 in this expression except this, because अगर यहाँ पे 2 put करेंगे then 2 minus 2 it will become 0. So that is overall it will become infinity. So this is minus 2 plus 3 divided by 2 minus 1. So this is 1 by 1. So b value we are getting as 1. Okay, so this is equal to b value, and b value we have obtained as 1. So now x of s it is becoming, so x of s it is equal to minus of s plus 3 whole divided by s minus 1 into s minus of 2, which is equal to a value is minus 2 by s minus 1 and b value is plus 1 by s minus 2. So now we have to find out the x of t expression. So let us apply the inverse Laplace transform. So we will obtain x of t. Okay, now it will be equal to 2. So Laplace inverse of 1 by s plus a, it is given by e to the power minus at into u of t. Okay, so we will use this expression. So here a value is minus of 1, so it will be equal to e to the power t into u of t. Okay, then plus it will become e to the power 2t into u of t. Okay, so this is the answer for this question. Now next topic is representation of circuit elements in S domain. Okay, so सबसे पहले हम circuit element consider करें, that is resistor. So as we know that resistor is the only energy dissipating element, and the amount of energy dissipated by the resistor is given by power into time. Okay, so power across the resistor is given by I square into R, which is also equal to V square by R. नाउ लेट अस सी एस डोमेन में कैसे हम रेसिस्टर को रिप्रेजेंट करेंगे. ओके, सो सबसे पहले लेट अस कंसीडर आर रेसिस्टर इन द टाइम डोमेन. ओके, सो this is resistor R. In the time domain the voltage across the resistor is V of t. Okay, and the current flowing through the resistor is I of t in the time domain. So now we know that V of t it is equal to R into I of t in the time domain. So now if we apply the Laplace, okay, so taking the Laplace on both the side, so V of t का जो Laplace है it will become V of s. Okay, and R will remain as it is, and I of t का जो Laplace है it will become R of s. Okay, so this is the equation, Laplace transform equation in the S domain. So using this equation we will draw the circuit in the S domain. Okay, so the resistor it will remain as it is. Okay, and the voltage across the resistor is V of S, and current flowing is I of S, and this is resistor R. सो इससे ये पता लगा कि एस डोमेन में जो रेसिस्टर है इट विल रिमेन आर ओनली. ओके, सो उस रेजिस्टेंस में कोई भी चेंज नहीं है, दैट इज इन द टाइम डोमेन आर इज देयर, सो एस डोमेन में भी आर ही रहेगा. ठीक है, नाउ लेट अस सी द नेक्स्ट एलिमेंट विच इज इंडक्टर. So we know that inductor is an energy storing element, okay, and it stored the energy in the form of magnetic field, and the amount of energy stored in the inductor, it is given by the formula half of L into I square, okay. So this much amount of energy is stored in the inductor in the form of magnetic field, okay. Now we have to find out how the inductor is represented in the S domain. So let us first consider in the time domain, okay. So simply I have considered a inductor, okay. So this is inductor, okay, in the time domain. So the voltage across the inductor is V of t, okay, and current flowing through the inductor is I of t. So now we know that the voltage across the inductor, that is V of t, it is given by L into d of it by dt, okay. So now if we take the Laplace on both the side, we are getting, so v of t का जो Laplace है, it will become v of s, then L, then using the property differentiation in time, what is the Laplace of dit by dt. so यहाँ पे क्या है, फर्स्ट ऑर्डर डेरिवेटिव है, so s की पावर 1 into I of t का जो Laplace है, it will be I of s, then s power will decrease, because अगर initial conditions present है, then we have to take into the consideration, okay. So s power 0 is 1 and it will be given by I of 0 positive. So we know that inductor does not allow the sudden change in current. So इंडक्टर के थ्रू जो करंट फ्लो कर रहा होगा, दैट इज एट t इज इक्वल टू 0 नेगेटिव, दैट इज जस्ट बिफोर द स्विचिंग ऑपरेशन, दैट करंट विल ऑल्सो फ्लो एट t इज इक्वल टू 0 and that current will also flow at t is equal to 0 positive, because inductor does not allow the sudden change in current. तो t is equal to 0 नेगेटिव पे जो इंडक्टर के थ्रू करंट फ्लो कर रहा होगा, t is equal to 0 पॉजिटिव पे भी सेम करंट ही फ्लो करेगा, ओके, बिकॉज इंडक्टर डज नॉट अलाउ द सडन चेंज इन करंट, बिकॉज in order to suddenly change its current, it will be requiring infinite voltage, which is practically not possible. So that is why the inductor does not allow the sudden change in current, okay. So now this v of s expression, let us expand. So it will be equal to sl into I of s minus L into I of 0 positive. सो लेट अस सपोज दिस इज इक्वेशन 1, ओके. सो नाउ इस इक्वेशन की हेल्प से हम ड्रॉ करेंगे सर्किट, दैट इज हाउ द इंडक्टर विल लुक इन द एस डोमेन. सो सपोज दिस इज इक्वेशन 1. नाउ लेट अस ड्रॉ द सर्किट, ओके. सो दिस इज v ऑफ s. सो वोल्टेज इज द सम ऑफ टू टर्म, ओके. सो वोल्टेज में क्या है, हम सीरीज में रिप्रेजेंट करते हैं, ओके. सो this is voltage and current flowing is I of s, okay. Now the inductor, it is becoming s into L, okay. So now inductor, it will become s into L, and अगर inductor initially charged है, then it will be represented by a voltage source, okay. Now the polarity is minus, so it means minus sign will come first, then plus, value is L into I of 0 positive, okay. So this is minus and voltage is v of s. So if you write the KVL equation, you will be getting v of s, it is equal to SL into I of s, that is the voltage drop across the inductor, plus फर्स्ट साइन इज माइनस एल इंटू आई ऑफ 0 पॉजिटिव. सो इट मीन्स इंडक्टर जो है एस डोमेन में L will be replaced by S into L, and अगर initial conditions है and you want to represent that initial condition with a voltage source, then you have to take the sign such that it will support that I of S current, okay. So इस तरीके से आपको voltage की polarity लेनी है कि वो I of S current को support करे, and the value is given by L, that is inductor value into I of 0 positive, that is current flowing through the inductor at t is equal to 0 positive, okay. Now if you want to represent in parallel, okay, then how you will represent, let us see. So let us find I of s expression from here. So it is given by I of s, it will be equal to, I think it is not visible, let me change the color, okay. So I of s, that is SL into I of s, it will be equal to V of s, then it will go on the left hand side, then it will become plus L into I of 0 positive. So let us find out the value of I of s. It is given by V of s by S into L, then plus it will become I of 0 positive by L will get cancelled out, so it will be equal to I of 0 positive by S, okay. So now this is equation 2. Okay, so let us represent this also. So here I of s is equal to v of s by sl. Okay, so यहाँ पे क्या है कि जो current है, it is a sum of, that is two terms, that is suppose it is I1 and it is I2, so it will be represented like this. Okay, so suppose the voltage is v of s and current, total current flowing is I of s. Okay, so first is inductor, so this is given by s into l. Okay, and it will be represented by the current source, and it is given by this. Okay, the value is I of 0 positive by s. Okay, so from here if you find the I of s expression, it is given by the current flowing through this sl inductor, it is given by v of s by sl, and then plus I of 0 positive by s. Okay, so these two representations are important. Okay, so it means s domain में जो है inductor, it will be represented as s into l. Okay, now let us see the representation of the capacitor. So capacitor is also an energy storing element. It stored the energy in the form of electric field, and the amount of energy stored in the capacitor, it is given by half of c into v square. Okay, so let us consider a capacitor in the time domain. Okay, so this is a capacitor. The voltage across the capacitor is suppose v of t in the time domain, and the current flowing through the capacitor is I of t. So now what is the relation between v and I in case of capacitor? So it is given by I of t, it is equal to c into d of vt by dt. Okay, so now let us take the LCM. Okay, it will become I of s. So I of t का जो Laplace है, it is given by I of s. Then c, what is the Laplace of d of vt by dt? So using the differentiation in time, it is given by s into v of s minus v of 0 positive. Okay, so now if the capacitor is initially charged, then v of 0 negative, it will be equal to v of 0, it will be equal to v of 0 positive, because capacitor does not allow the sudden change in voltage. So it means t is equal to 0 negative पे जो capacitor के across voltage है, that voltage will be at t is equal to 0 positive, because capacitor it will not allow the sudden change in voltage. So जो voltage है t is equal to 0 negative, t is equal to 0 and t is equal to 0 positive पे same value रहेगी. Okay, so from here we are getting the I of s expression. It will be c of s into v of s minus c into v0 positive. So it can be written as I of s, this can be written as v of s divided by 1 by cs minus of c into v of 0 positive. So let us suppose this is equation 1. Okay, so now let us represent the capacitor in the S domain. So it will become, voltage is V of S. Okay, so the voltage is V of S, total current flowing is I of S. Then the capacitor in the S domain, it will be represented by, voltage is V of S, so this is V of S by 1 by Cs. So now the capacitor in the S domain, it will be represented by 1 by Cs. Okay, and here the current value is minus of c into v0 positive. So because of this minus sign, it will be opposing the current. Okay, so I of s current को वो oppose करेगा, so it means the current direction will be in the upward direction. So this is c into v of 0 positive. Okay, now let us represent the equation using the v of s. Okay, so let us find out the v of s expression from here. So cs into v of s, it will be equal to I of s, then it will be plus c into v of 0 positive using this equation. So from here we are getting v of s, it is equal to I of s into 1 by cs, it can be written as, then plus it will become v of 0 positive by s. Okay, so suppose this is equation 2. So now voltage ka equation given hai, then it will be represented in series. Okay, so now this is capacitor, it will be represented by, current flowing is v I of s and voltage is v of s. Okay, So now capacitor value is 1 by Cs, okay, and the voltage source is plus V of 0 positive by S. It means upward polarity will be plus and downward polarity will be minus, okay. So this is minus and value is V of 0 positive by S, okay. So it means the capacitor in the S domain, it will be represented by 1 by Cs. So now if you want to represent it with the current source, the value will be C into V of 0 positive and it will oppose the current, okay. And similarly if you want to represent in series, it is given by 1 by Cs and the value of the voltage source is given by V of 0 positive by S, and here also it will be opposing the current, okay. So now let us see a question. In the following circuit the value of Z of S is, okay. So now we have to find out Z of S, that is we have to find out the impedance in the S domain. So सबसे पहले हमें जो सर्किट गिवन है उसे हमें S डोमेन में कन्वर्ट करना होगा, ओके. सो यहाँ पे क्या है कि R, L, C, all the elements are given, okay, and inductor and capacitor उसके across initial conditions हमें नहीं given, so we will not consider, okay. So let us draw the circuit in the S domain, okay. So draw the circuit or the network in S domain, okay. So first element is capacitor, so and this is resistor, okay, and this is inductor and again this is resistor, okay. So this is Z of S, okay. Now we have to find out Z of S from here. So in the S domain the capacitor is represented by 1 by Cs, okay. Initial conditions nahi given, so we will ignore, okay. And the resistance in the S domain remain as it is. Inductor is represented by S into L and again this is resistor, its value is 1 ohm. So यहाँ पे क्या है, capacitance and inductance की value given है, so let us substitute. It will become, so C value given is 1 farad, so it will become 1 by S, okay. And resistance value is, this is 1 ohm, okay. And L value given is 2, so it will become 2S, okay. And this is resistor, this is 1 ohm. And we have to find out Z of S, that is impedance in the S domain. So now 2S and this 1 ohm, they are connected in series. So Z of S is given by, so 2S and 1, it is connected in series, so it is 1 plus 2 into S and it will be connected in parallel with 1, okay. So this is connected in parallel with 1 and then it will be connected in series with 1 by S, okay. Then it is connected in series with 1 by S and then plus 1 and 1 plus 2s, they are connected in parallel. So let us simplify, okay. So this will become 1 by S plus, so when the two impedances are connected in parallel then the Z equivalent, it is given by Z1, okay. So when the two impedances are connected in parallel then Z equivalent is given by Z1 Z2 by Z1 plus Z2, okay. So this will become 1 into 1 plus 2s divided by sum of both the impedances, that is 1 plus 1 plus 2s. So from here we are getting Z of S as 1 by S plus 1 plus 2s divided by 2 plus 2s, okay. Now let us take the LCM as S into 2 plus 2 into S, so it will be 2 plus 2s plus S into 1 plus 2 into S, okay. So this will be equal to 2 plus 2s and then it will be equal to S plus 2 into S square. Let us also expand the denominator, so it will be equal to, so it is 2s plus, this is 2s plus 2 into S square, okay. So this will be equal to 2 into S square plus 2s plus S, it will be equal to 3s plus 2 divided by, let us take 2 into S, okay. So let us take 2s common, so it will become S plus 1, okay. So let us see the options. It is given S into S, in the denominator it is S into S plus 1 form, okay. So let us write in that form. So it will be equal to 2 into S square plus 3s plus 2 divided by, so let us take 2 outside, so it will be equal to s into s plus 1. So let us divide the numerator by 2. So z of s, it will become 2s square by 2, so it will be equal to s square, plus 3s by 2, it will be equal to 1.5 of s, then 2 by 2, it will be equal to 1 divided by s into s plus 1. Okay, so this is matching with the option, so 1.5 is ऑप्शन ए. ओके, सो दिस इज करेक्ट आंसर. सो आज के लिए इतना ही. नेक्स्ट लेक्चर में हम लोग देखेंगे नेचुरल रिस्पॉन्स, फोर्स्ड रिस्पॉन्स एंड ऑल्सो द कॉन्सेप्ट ऑफ इनिशियल कंडीशंस. सो अगर आपको वीडियो अच्छा लगा हो तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें. थैंक यू.